Let's continue our interview preparation, guys, and thanks for giving lot of love to the previous video. So this video we will be seeing remaining 10 questions from the list of our original 20 topics that we chose for any AI interview in 2026. Let's start. Okay guys, so let's pick up from where we have left last time. And if you remember, we have covered the topics like RAG, AI agents, function calling, multi-vector embedding, diffusion models, vision language model, LoRa, model distillation and quantization. Today the first topic we are going to understand is AI safety and guardrails. So prompt optimization also we discussed last time, but AI safety and guardrails is something where we will start with. Now this topic comes and revolves around responsible AI, fair use of AI, etc. So there is a high chance that if some leader is interviewing you, they will touch upon this topic. Just understand that AI safety and guardrails can be from two sides. Okay, so suppose you are an AI user. A AI user can also do something wrong, and the AI system can also do something wrong. If you see the high level architecture here, right, user input, and then at input level you put some guardrails. This is what you do to protect your system from the users, but this is not enough. Once LLM processing happens, then output guardrails are also needed. Okay, so just have this idea in your mind. You need to have guardrails at two ends, at user end and at LLM end as well. What can happen at user end? At user end, jailbreak execution can happen, jailbreak detection you need to do, toxicity user can do, PII detection you need to do, policy rules you need to see. At output level, you need to do harmful content filter, hallucination detection, PII reduction basically, and bias check. So these are some of the things that when you are passing the message to the end user. Now what I have written here, AI safety prompts prevent harmful outputs, enforces policy and ensure responsible AI deployment. Guardrails. What are guardrails? Guardrails filter input output, detects toxicity, prevent jailbreaks and enforce content policies through multi-layered defense system. So one layer of defense is not enough. Why it matters? Very simple to understand. If you are building any public facing AI system, you need to have that. Responsible AI, as I was telling you, people will just sit on your head if you don't do all these things, because they are the people who are there to ensure that AI is fair, transparent and responsible. Okay, critical for user trust and brand protection obviously, and this is a must know topic for production AI discussions. Remember this diagram and remember at two ends you need to do this. Okay, now whatever we learned, what are the different things? So principal multi-layer protection is needed. Input validation you need to do, for example jailbreak detection. What is the example of a jailbreak? So there are some patterns through which I can make your model behave in a certain way, or suppose your model is not allowed to give information on stock broking. So I write a prompt in such a way that your model can give me stock advices. For example, you can see here common patterns in jailbreaking: ignore previous instructions or system override. In detection methods, you can detect the pattern by semantic similarity or pattern matching, and there are multiple things. Similarly, you can do different kinds of input validation, like toxicity check before processing, PIA detection before processing, sensitive information detection. All these things you can do. As I was telling you, when your system is generating output, here also you can do things. Some policies are also there which can be put in input and output both levels. So these could be custom rules for domain specific policies. For example, no medical advice, no financial prediction. These things also you need to put. Some interview questions I have put as usual for you. You can go through this. And real world application, obviously guardrail you need to put. Anywhere you are talking about AI in production, you need to put guardrails. Okay, remember this always. Guardrails a very important topic. Next one, a very interesting one, vector databases and indexing. Now I am sure you know what is a vector DB. If you don't know, I have given a link here, guys. You can watch these videos and you can understand what is vector databases, how these work. But just understand that vector databases are the databases where you normally store your embeddings and do all kind of LLM retrieval, fetching, matching, etc. Okay, Now what is happening is our AI application size is increasing in terms of model parameters or the length and breadth of the application, right? So what's happening is our vector sizes, typical way of matching, typical way of indexing, typical way of putting the data is not enough. So what's happening now is different new kinds of architectures are coming. Okay, one architecture is called HNSW, another architecture is called IVF. What are these architectures? So I'll give you a high level understanding here. Suppose in HNSW architecture there are different nodes at different levels. For example, in layer 2 you have only 2 nodes, in layer 1 you have 3 nodes, and in layer 0 you have 1 2 3 4 5 nodes. So this is your HNSW architecture. What is happening here is multi-layer graph structure where upper layers have fewer nodes. Search starts at top and navigates down layers. Parameters M, that is connection per node, EF construction build quality, EF search quality. The benefit is, imagine all these vectors are basically put in a DB and somebody goes and hits the entire database. But this one is a better way of finding the relevant match. So what it's saying is fast approximate search with high recall, trade off higher memory than IVF. Basically you need more memory for this, but the thing is it will be a faster. So basically it will go node by node search and it will go to the needed nodes fast. That is one way of storing your vector embeddings, not a traditional way of storing embeddings. Okay, the other way of storing embedding is IVF structure. What is this? As clear from the picture, you will have different clusters. So in cluster 1 you have, for example, 2 vectors, and these two guys are near to each other. Okay, in cluster 2 you have V3 and V4. These two guys are near to each other, I mean close to each other. Cluster 3 V5 V6 and V7 V8 in cluster 8. Understand like cluster 4, understand like K means clustering where similar elements are together. Okay, and now someone comes and tries to search. When they try to search, then cluster by cluster mapping will happen, and then the actual vector. See here, IBF, inverted file index, partitions vector into cluster. Search finds nearest cluster, then searches within that cluster. Benefit, scalable to billions of vector. Variance, various variants are here. The trade-off is may miss vector near cluster boundaries. Same problem that you see with k-means clustering. Okay, but this has been found as a nice way of using vectors. These two, HNSW and IVF both. What is product quantization in vector? At the moment you hear quantization, always remember it is compressing vector into memory efficiency. Okay, what is approximate versus exact search? Obviously approximate means it will do different kind of search, and exact means, see here, exact search provides 100% recall but is slow, brute force. Approximate is fast but may miss some results. So two different ways of searching. Okay, and combination hybrid indexing of vector, basically like this. You can take a combination of IVF plus PQ or HNSW plus quantization, etc. So inside vector DB itself, multiple things are happening. You need to be aware of those and read these interview questions. And there are applications of this Pinecone, VV8, Milvus, Elasticsearch. I am giving you some nice video links. You should watch these. Okay, these are important for you. The next important topic and very interesting one again is related to scaling laws and something known as Chinchilla Optimality. What is this in very simple plain language? If you go few years back, right, everybody was thinking if I increase more data and if I increase more number of parameters in my model, then I am always going to get a better model. Okay, but there is a law come into the picture, and what that law is saying, there is a proportion you need to follow. If you don't follow that proportion, you are not going to get the benefit. So if you see here, right, this law is called scaling law, and this is basically a mathematical formula, a multiplied by c to the power minus alpha. No need to remember all this, but you need to just see this part. For what is Chinchilla optimality is basically for fixed compute, which means suppose you are having a computation power of some power, you can assume. Okay, In your model, if too many parameters are there, which n means number of parameters, okay, and d means data. If parameters are too much and data is low, then you are going to get overfitting. If parameters are low and data is high, you are going to get underfitting because model is not able to learn only. So the optimal what this law says is d by n should be roughly 20 tokens per parameter. So basically, if the model is having, let's say, one parameter, then the training data should be 20 tokens, and then you are going to get the optimal model or optimal performing model basically. So this law is giving guidance to anybody who is trying to train a new large language model basically. So here you can see scaling laws describe how model performance improve with compute data and model size. Chinchilla Optimality shows optimal token to parameter ratio 20:1 for training efficiency, challenging the assumption that bigger models are always better. Here why it matters, obviously critical for budgeting, critical for architecture decision, cost effectiveness, common topic in architecture discussion. So if you are a senior data scientist, be aware of this law. Okay, what are the key concepts? Powered law scaling that you saw here, this thing. Chinchilla scaling that you saw here, that I explained you, 20n thing. Okay, based on this you can compute your budget allocation. Okay, and then emergent ability, capability appear at scale threshold. Scaling law help predict when abilities emerge. So in context learning or few sort capabilities can be used for planning model development. What are the limitations? So assumption is sufficient data quality, architectural improvement may break at extreme scales or with architectural change, but roughly this is a industry accepted thing now. Okay, some interview questions you can see here on Chinchilla law, and real world applications could be Llama for training, GPT for development, model architecture research, training budget planning, whatever we discussed. Very important, remember this, anybody can ask you about this. Okay, remember 21 ratio. Synthetic data generation, one problem that if you are into machine learning or data science or AI since some time, then this is not a new thing for you, right? Synthetic data you need. Why you need synthetic data? You need for training, you need for testing, you need for validation, many purposes. What is the high level structure? You need real data and you can generate data through LLM. So basically nowadays LLM also can generate our data through diffusion models. So images, videos, etc. we can generate through diffusion models. Diffusion model is one topic here as well. Okay, topic number 5. And then synthetic samples comes once you generate the data, and then you need to put some filter, for example validation, diversity check, realism check, and then your training data or validation data or whatever you call it gets prepared. So if somebody asks you what are the different ways to generate synthetic data nowadays, it could be LLM based, it could be diffusion based, it could be traditional rule based, the way we used to do in the past. Okay, this is your architecture and I have given you a video here. Synthetic data generation, use LLM diffusion models to create artificial training data, often preserves real data properties while addressing scarcity and privacy. These videos you can see, I have spoken explicitly about this topic. Okay, synthetic data generation. Real world applications, some data is given here that you can read about, interview questions. And basically here I am saying LLM based generation you can generate from LLM, you can generate from diffusion, you can check for quality, you can seek privacy preserving, domain specific generation also you can do. Okay, so all these are part of synthetic data generation. Be aware of this, be aware of this entire concept, the pipeline, what is useful here, what is that you need to know here, right? The next topic, very interesting, one of my favorite topic, LLM evaluation. Okay, every time you use an AI system nowadays in generative AI, you need to evaluate that. You will evaluate for what? That is important. So there are different evaluation frameworks. You can evaluate for task metric, you can evaluate for RAG metric, you can evaluate for embeddings, you can evaluate for safety, you can evaluate for efficiency, right? And in the bracket I have written things here. If you are evaluating on task, you need to see accuracy, F1, blue, row, etc. If you are evaluating on RAG, you need to see faithfulness, answer relevance, chunking. You can do evaluation on toxicity or whatnot, right? Embedding metrics, retrieval accuracy, basically. Safety measures, toxicity, bias, unfairness, all these things you can see here, whatever we discussed in guardrails. Efficiency metrics, latency, cost, the throughput, all these things you can measure here. So evaluation, remember, can be done on multiple fronts, and these are the different individual items on which you can evaluate your LLMs. Again, definition of all these I have given: faithfulness, what is faithfulness, what is context precision, what is citation accuracy, what is retrieval accuracy, what is toxicity, how do you check, efficiency metric, how do you check. All these things important for you if you want to attend an AI interview in 2026. People will ask you any generative AI application, how will you evaluate that, and you need to talk all these things. Remember, you have to talk confidently. There is no one who knows everything in these areas. Okay, be confident and talk on these things. I have given you a video link here which you can watch and learn more about these topics. Let's move to the next one, memory systems. Again, one important one. What are memory systems? So what happens is, when you interact with LLMs, there could be different type of memories. Okay, one memory is the in context memory. Suppose you are chatting with Gemini or ChatGPT, that is one context memory, that is called short term memory. Okay, then there is long term memory, which is in external storage, maybe a knowledge base or something. And then there is a episodic memory, that is about specific events or persistent context aware AI assistants. For example, suppose I tell to ChatGPT, give me a code in Python, give me a code in Python. ChatGPT will understand this guy always wants code in Python. Maybe he is a Python guy. So that is kind of episodic memory for persistent context aware AI. So basically what we are learning here is, in memory there are different types of memory, and all these memories are useful for your AI system. Okay, so if you see here, right, current conversation is a short term memory. When you are doing memory retrieval, you will do query past memories and you will rank by relevance. So here it will come different kinds of memories. And then long term memory is episodic memory, semantic memory, and vector store embeddings, basically the knowledge base, you can say. So many types of memories are coming into picture, and if you take all these memories, you are going to get enhanced context and better response. Obviously LLM will know more about me, right? The key concepts here is short term memory and long term memory. Short term memory, as I told you, current context window. Long term memory, external storage, that is on demand. The trade off is short term memory is fast, long term memory is scalable but slower. So you need all kinds of memory. Okay, what is episodic versus semantic memory? Episodic means specific events, like Python example I gave you, right? User said X on date Y, so that is one episodic memory. Semantic memory is general knowledge, so this one is basically Python one that I told you. What user prefers, that is a general knowledge kind of memory. A specific event is, let's say I told somebody, I told to LLM to do something on a particular day. Maybe I told that today is my wife's birthday, so maybe LLM will remember, okay, this is Aman's wife's birthday date. That is one kind of specific event memory. Then generic memory, then long memory, short memory, many types of memory here. Okay, memory retrieval is query based, search memory, current context, vector search. Then there is a concept of memory compression and forgetting. So memories grow unbounded. Solution: summarize old conversation, prune low importance memories, and it has to be time based, importance based. Remember these concepts. Okay, and then multimodal memory, there could be text memory, images memory, there could be metadata, etc. So a lot of things in memory system of your LLM. Whichever topics you are interested in, you can search more about that. Here are some critical interview questions for you, and applications, basically all the AI systems, and a summary of this. Okay, a very important topic for you to know. Next important topic for you to know is graph RAG. I have a detailed video on this, guys, and you don't need to know anything else if you watch that video. So I have given here graph rag for beginners this video, you must watch this. So what happens in graph rag is all the knowledge is stored in terms of graphs. And what is graph? Graph is a combination of nodes, entity and relationships. So what is node, entity and relationship? Suppose Aman is a node and Aman works in ABC company. So there will be a graph created. Aman, the relationship will be works in, and the other entity will be my company name, okay, ABC. See here, documents, and then from documents it will come entity and relationship extraction. Entities are nodes, for example Aman in my case. Relationship is the edges, for example Aman works for ABC. And when you create that kind of graph, it is called as a knowledge graph, okay. And then you fire the query and then find relevant entities, and matching will happen from the nodes, from the relationship. Then context will get generated and then LLM generation will happen, then answer with graph context. So you can think of RAG in terms of graph. That's it, okay. Knowledge stored in terms of graph. So graph RAG combines knowledge graphs with RAG, using graph structure to enhance retrieval and reasoning. Entities and relationship are stored as nodes and edges, enabling multi-hop reasoning and structured knowledge queries beyond traditional document retrieval. Fine, this is the structure. And as I told you, knowledge graph construction is basically name entity kind of construction. Graph retrieval versus vector retrieval. Graph uses structured relationship, vector uses semantic similarity. Graph better for multi-hop reasoning, vector better for semantic similarity. Hybrid, you can combine both. Multi-hop reasoning means, one example is here. Single hop means direct relationship, multi-hop means indirect relationship, ABC. Example, who works with Einstein? Find collaborator. This is an example, okay. For example, if I work in ABC and you ask who works in ABC, then if somebody else works in ABC, that name will also come because that is connected to ABC. You get the idea, right? So multi-hop reasoning. And then graph embedding is basically node embedding happens. Then graph you can use and vector method also you can use, and you can go for hybrid. So that is your graph RAG or graph databases, okay. Please watch this video, guys. This is a very important video for this topic. It's not very difficult to understand. You can easily understand this topic, okay. The next one, not very difficult to understand again, is various reasoning methods used by LLM nowadays, okay. And some of these we have discussed before, but this is called problem. POT means problem of thought, right? Program of thought, okay. Program of thought. Program of thought, what it does is it creates a code basically. If you see here, problem, generate code, then execute, then use result, and then answer. So when LLM thinks, it will generate a code in between. That is called program of thought. Remember this. Tree of thought means to solve your problem, LLM will generate multiple trees and multiple paths. So path 1 is this, path 2 is this, path 3 is this, and then it will evaluate which path to take, which tree to prune, and then it will take the best path and give you the answer. This is called tree of thought. And tool augmented flow is problem, reason, use tool. So an advance of this will be agentic AI and multi-tool AI systems. But this approach of thinking is called tool augmented flow. So what we are writing here, advanced reasoning techniques enhance LLM problem solving. Program of thought uses code execution. Tree of thought explores multiple paths. Tool augmented reasoning combines external tools. These methods enable complex reasoning tasks requiring computation on exploration. Why it matters? Because problems are getting complicated nowadays. You need different methods to work on various problems. As we saw, in program it will create a program, in tree it will create different trees, in tool it will use various tool. Self consistency is another way of working with LLM, where you say that generate multiple independent solution, vote on one answer. This is one way you work. And then reflection is basically you ask LLM to check its answer. So self critique and refine solution iteratively. So you will ask LLM to generate, then critique, then refine, then repeat, okay. So what LLM will do, it will generate, then critique its own answer, and then refine and give you the better answer. This is another way. This is called reflection. Some interview questions here, guys. This is the summary you can see, and real world applications, obviously lot of application for all of these thought processes. Next one is cloud native inference. Some people who are into the cloud, some interviewers who love cloud technologies and deployments, they will touch these areas. Remember, whenever we are talking about cloud or deployment, we will always talk about cost, inference time, the latency, the batch management, the security, all these things we will talk about. Okay, at a very high level, you will receive a request from the user. You need to have a load balancer so that your user does not get pissed off. Then you will have the inference engine, then you will have the GPUs mostly, and then you will give the response. Okay, in load balancer you can do batching, auto scaling. In inference engine you can do paged attention, memory optimization. Now lot of these things will be new to you, so let's see most of these one by one. Okay, what is the overview we are looking? Cloud native inference system optimize LLM serving for production. VLLM use paged attention. Remember this keyword, paged attention, for efficient memory. Triton provides, or Triton, whatever it is, GPU optimized kernel. Serverless enables auto scaling, critical for high throughput, low latency LLM development. Don't worry about those terminologies, guys. I'll tell you very simply. Okay, paged attention is nothing but you store the KV cache page by page. See, manage KV cache in fixed size pages. So what happens is, in your attention layer there is KV, right? That is getting managed page by page, and this is basically non-contiguous memory, so better memory utilization. As you can see here, better memory utilization, that's it. What is continuous batching? In place of fixed batch size, you create batch based on, see here, dynamically add remove request from the batch. So based on how the requests is, you can decide your batch size. So you will not have a fixed batch, so you will get a 3 to 5 throughput improvement. Tensor parallelism means when your model size is huge, what you do is you distributed the parts of it between different GPUs. That works in parallel. That is called tensor parallelism. See, split model across multiple GPUs. Benefits: serve large models, single models than single GPUs. Each GPU handles subset of layers. Okay. Use case: models larger than single GPU. Quantization, making models small by reducing the size of numbers storage. Serverless inference: if you are going into cloud and you want to go serverless, obviously you don't need to take headache of load, elasticity, security, etc. Everything does by the platform. So auto scale based on demand, benefit pay per use. These are the things you should know when you are talking of cloud native inference, and few more things obviously. Read these interview questions, read about these applications. I have videos on AWS Bedrock. You can search Unfold Data Science AWS Bedrock and you will get the video. And production APIs also I have videos. You will find that if you search. Some of these terms interviewer might touch, hence I have put it here. Okay. And last but not the least, guys, AI system design. So AI system design is very similar to traditional machine learning system design, apart from you need to take care of few extra things here. For example, nowadays you need to see how you will serve the model, because model sizes are big, user requests can be more, and cost, security, all those aspects will come into picture. So basically there will be data source, there will be pipeline, feature store, model training, model registry. Then the user request will come, you will receive that through API gateway, you will serve the model, you will maybe hit the cache and get the response, and then monitoring and logging and feedback loop. So these are the things you will do when you are building a end-to-end machine learning or AI system in today's world. AI system design encompasses end-to-end architecture for production AI applications, data pipeline, serving, monitoring, scalability, combine ML software engineering and infrastructure for reliable, scalable AI products. So you are going to build reliable and scalable AI products, then you need to keep in mind all these things. Okay. Why it matters? Obviously, if you want to serve your model to someone, you can't serve without this. Data pipeline, how do you ingest data? Model serving, API layer, how do you serve it? Monitoring, how do you monitor your model for accuracy, latency, throughput, data drift, model drift, etc. Scalability, how do you scale it horizontally and vertically both? if your model is reliable or not reliable, that also you need to see, and you need to fall back. You need to have a fallback mechanism basically on that. If something goes wrong, then where are you falling back? Some important interview questions on this topic, okay, and summary of this, you can read more about this. So these 20 topics, I know guys, it's a lot, okay, but believe me, if you go through this and you go to an interview, right, I'm sure some of these they will touch, and some of these keywords, if you know, you will be in a much better position to answer them, okay. Any topic you go, there is many more things you can read, you can search, you can read, but at least this much you must know. I put lot of effort to create this, guys. Please give me a thumbs up and like if you want. And I have already put this in Git. I will just make it public and share it with you. Either you can read directly from here, like in the Git itself, MD file, or you can launch that using start server. So I have given in the read MD, okay, how to launch that. You can simply run python mhttp server and it will get launched like this, and you can read in browser, or you can do here only, your choice, okay. I'll share this with you, okay. Fine guys, see you all in the next video. Wherever you are, stay safe and take care.